Hello everyone, this is Charlie from the Bloomingdale Public Library, and today we're going to be discussing how to implement some basic physics in Blender. Before we get started, what is physics and why are we implementing them in Blender? Well, the dictionary describes physics as a science that deals with matter and energy and their interactions, while the Blender docs describe physics as a system that allows you to simulate a number of different real-world physical phenomena. Basically, instead of manually animating our objects, we're going to add some physics properties to our objects and let the Blender physics engine do the work for us. The effects of physics properties are only evident over time, meaning these effects are primarily for creating videos. I originally started doing Blender videos to help promote our 3D printing program over at the Bloomingdale Public Library. So while you could creatively incorporate what you learn in this video to the models that you submit for 3D printing, you're primarily going to want to look at some of our previous videos to get started. Physics are a type of object property found in the Properties panel, meaning we're going to spend most of our time working with the Properties panel and all the options in there for this video. And some physics properties will also appear in the modifier stack, which we've also discussed in previous videos. Basically, in the modifier stack, all the modifiers are applied to an object sequentially, meaning if you change the order of the modifiers in the modifier stack, you can get different results. However, we're not going to be messing around with the modifier stack today. Just a few more notes about Blender physics before we start to play around with them. When physics are applied to an object, your Blender video becomes part physics simulation, and this is reflected in the tooltip descriptions. Objects can either be controlled by physics simulation or keyframe animation. In fact, both methods can be implemented on the same object in the same scene, just not at the same time. For example, you can control a flying character with keyframes and then use gravity to land them. Manually animated objects can still have physics properties applied. For example, that character that you're controlling with keyframes can still fly around and collide into objects that are controlled by physics, and you do that to make the collisions a bit more realistic. Part of physics simulations is collisions. How objects collide depend on their physics properties. There are a bunch of different types of physics systems available in Blender. A couple we'll look at today are rigid body, soft body, and fluids, and they don't interact by default. In fact, even when you do get these systems to interact, you usually got to do a little extra tweaking in order to get things to work properly. We might take a quick look at an example of this, but otherwise I'm not going to dig too deep into the weeds on this one. One final note, physics simulations, depending on what you're doing, can get very CPU intensive even outside of render mode. So I'm not going to be rendering anything today, and anywhere I can, I'm going to be keeping the settings relatively low. And that's just because I'm recording at the same time and working on a 5-year-old laptop, and I don't want things to get stuttery. Alright, so it's time for our first Blender physics simulation. We're going to basically end up with a bunch of cubes falling through a torus onto a floor. We're going to build the scene up one step at a time. So we're going to start off, we're going to back up a little bit. And with our cubes still selected, I'm going to hit G to grab, Z to lift on the Z axis, and pull it up like that. Next, we're going to go to Add, Mesh, Plane, then S to resize it, use the mouse, stretch it out, and click to set. Alright, so we've got one cube and a floor. Let's pull up our timeline just a bit here. I'm going to restrict us to 100 frames. Like I said, I want to kind of minimize the numbers here. Let's go ahead and play and see what happens. Absolutely nothing. Go ahead and stop that, drag the playhead back. This is because we didn't animate anything and we haven't added any physics yet. So let's go ahead and do that. In addition to the physics, I'm going to add some color just to make things a little easier to see. So I'm going to go to the top right here, click on Viewport Shading. I'm going to click on our cube here, and then the Materials tab, which is the little sphere, and Base Color. We'll make it yellow. Alright. I'm going to click on the plane. Okay, the Materials tab is already open. I'm going to click New, Base Color, and make it blue. Alright, so now with the colors in place here, let's add some physics. I'm going to click on our cube here, Go to the Physics tab, which is this little moon going around a planet, I think. When I click on that, you see our options. Again, we're going to do rigid body. Leave all the defaults for now. Go ahead and play. And there we go. Now we got something happening, although it's not quite what we want. We'll stop that. Bring the playhead back. Let's go ahead and select our plane here. Give that some rigid body physics too. Alright. Hit play again. And if that's what you thought was going to happen, congratulations, you get a gold star. Go ahead and bring everything back. Now to keep our floor from reacting to gravity, what we're going to do is go over here to the rigid body options here on the right side, and under type where it says active, we're going to change it to passive, which means it'll still interact with collisions, but it's not going to interact with forces like gravity. So let's go ahead, hit play now, and there we go. That's kind of what we want. Let's go ahead and add a few more cubes just to make things interesting. I'm going to select the cube and hit Shift D to duplicate and just drag them around. Okay. Looks good. Let's go ahead and play. And there we go. We've got 4 cubes just kind of crashing into the floor like that. A note about rigid body physics, and probably all the other ones as well, is if you were to say have 2 objects start off overlapping, the engine thinks a collision has already happened. So if I hit play now, you see they just kind of fly apart as if the collision happened before the scene started. So maybe that's what you want, but otherwise you probably want to make sure your objects all have some space. Okay, so one more part to this scene is a torus, and we want to have our cubes dropping into the torus. So we're going to go add mesh torus. I'm going to hit G and then Z to lift it off the floor. Hit S to stretch it out a bit. Make sure things are lined up. Okay, that should work. And then we want to go ahead and hit rigid body. Make type passive because we want our cubes to go through the torus. We'll leave it white. Why not? We hit play. And it's probably not what you were expecting. So our issue here is, if I stretch things out a little bit here, I still have the torus selected. Under collisions, it has its shape set to convex hull. If I roll over, the tooltip description says that you're basically shrink wrapping your object when you use convex hull. In other words, we're not figuring for the hole inside of our torus. If you need your physics to be a little more accurate, if you click on convex hull, you'll see there's a bunch of other options here. What we want is mesh. You see there's a bunch of other options, and you want to use those if you can because it'll help minimize the taxing on your CPU to have a simpler shape. But if it doesn't work, it doesn't work. So we're going to set our shape to mesh, pull things back, hit play, and there we go. And that is our first simulation with rigid body physics. Okay, time for our next simulation. It's going to be another rigid body simulation, and this time we're going to recreate the examples that I mentioned during my Blender notes. And the whole point of those examples was that you can mix animation with your Blender's physics simulation. So we're going to start off with a stack of cubes, and go to Add, Mesh, Cube, hit G to grab, Z to pull it straight up, oops, GZ, and then click to set it. Again, make sure that there's some space between the cube and the plane, otherwise they're going to collide right off the bat and everything will go flying. I'm going to make it just a little closer. Okay. Just for effect, I'm going to go to the Material tab, click New, click on the base color. We'll make it orange. Kind of like a brick wall. Next, we're going to go to the Physics tab, click on Rigid Body, leave the defaults. To make a stack of 4, I'm just going to hit Shift D to duplicate, G to grab, Z to stick to the Z axis, and again just put it just above the one below it. 2 more times. Shift D, G, Z, put it just above. Shift D, G, Z, just above. Make sure you're on frame 0, otherwise you're probably going to have trouble doing this. Okay, time to add our colliding cube. We're going to go to Mesh, Cube, G, Z. We want to line it up between the second and third cube. So that's going to be where our collision happens. G, and then Y to pull it straight across and make sure we're going to hit it square on. And then again, for effect, we're going to go to Material, New, click on Base Color, and make it red. So basically, this is going to be like a Kool-Aid simulation where Kool-Aid Man goes through the wall. Click on the Physics tab, click on Rigid Body, and now for settings, make sure the animated box is checked. So this way, we can actually animate this cube with keyframes. To do that, we're going to click on Object, and then over Location, we're going to hit I, and that'll create a keyframe on frame 0. And sure enough, you have the little diamond on the timeline. Next, we're going to go to frame 60, grab our cube, G, and then Y to go along the Y-axis, and anywhere past the stack of cubes, go ahead and click. Go back over the location properties, hit I again, and we have another keyframe. Let's go ahead and see what this looks like. I'm going to drag the playhead back to 0, click play, boom. And that is how you have an animated object with physics properties that allow it to interact with other objects that are only controlled with the physics engine. Incidentally, that's kind of cool how the top box kind of lands right on the bottom one there. Alright, so we're going to stop that, go back to the 0 frame, and now we're going to go ahead and have our cube land after it's done with the physics engine. So we're going to go back to the Physics tab, again with our Kool-Aid Man cube selected, and you'll notice that the animated property has a dot next to it. And if you don't remember from previous videos, it means that property can be animated. So what we're going to do is on frame 0, I'm going to go ahead and click I over the animated property there. Next, we're going to go to frame 60, uncheck the animated property, and hit I again. So now at frame 60, the cube will no longer be controlled by the animation engine and should default to the physics engine. Why you're allowed to have everything checked at the same time, I'm not really sure. So let's go ahead, play it along, see the collision happens, and then the cube falls to gravity. So again, we recreated the examples from the notes showing that an object can interact with physics-controlled objects, even if it's animated, and then you can switch between animated and controlled through the physics engine. Next, we're going to talk about cloth. To do that, we're actually going to start with our default cube here and give it some physics. To do that, with the cube selected, go to the Physics tab, click on Rigid Body. For type, let's set it to passive so gravity doesn't take it away. Next, we're going to add our cloth. And to do that, we're going to go to Add, Mesh, Plane. And I've actually got some specific settings I want to put in here to make a demonstration later. So we're going to hit G, Z, 3 to move the plane 3 meters above the origin, then hit Enter. Next, to resize the plane, we're going to hit S, 1, 0, hit Enter again. To make things a little easier to see, we're going to give the plane a color. So we're going to go to the Materials tab, click New, and for base color, we're going to click on the color and set it to something dark. I'm going to go with a dark blue. In order for that to show up, again, we got to go to the top right corner here and click on Viewport Shading, and now we're ready to go. To add cloth physics to the plane here, all you got to do is go to the Physics tab, click on Cloth, and let's see what happens with the default settings. Sure enough, the cloth goes right through the cube. You might recall me saying earlier that the physics systems in Blender do not interact with each other by default, and we have a rigid body interacting with a soft body. So to get things to interact, I'm going to click on the cube here, and then under the Physics tab, I'm going to click on Collision. And when I do that, you'll see we have some new settings here, and some of those underneath Collision relate to soft body and cloth. So now we've got some settings for colliding with soft bodies. So things should be interacting now. Let's go ahead and hit play. And sure enough, our cube now collides with the cloth. Now you may have noticed our cloth doesn't really seem to behave like cloth, and that's because cloth will only bend at the vertices, and in this case our cloth doesn't really have any besides at the corners. So let's go ahead and fix that. With the plane selected, we're going to go to Edit Mode, and then right click, and then the first option there is Subdivide. So I'm going to do that 4 times. The more subdivisions you have, the better the cloth simulation will be, but will also tax your CPU a bit more. So you might have to do a little bit of a balancing act. Alright, we're going to go back to Object Mode, bring the frame back to 0, hit play. That looks a bit better. If you don't want the individual faces showing up on the cloth, what you can do is select the plane, make sure you're in Object Mode, right click, select Shade Smooth, try again, and that looks pretty good. So next we're going to look at things when they do not look pretty good. So what we're going to do is, with the plane selected, go into the Physics tab, and where it says Vertex Mass, instead of 0.3 kilograms, we're going to set it to 3. That's going to make this cloth very heavy, and things are going to be moving a lot faster. Let's go ahead and hit play and see what happens. So you can see we've got a lot of clipping going on. The cloth will clip with the cube and with itself, and then eventually we just lose the cloth altogether to gravity. There it goes. So the first thing we can do to fix this situation is, the first option under cloth is quality steps. If you roll over that, you see the tooltip says this is how many times per frame we're checking the simulation math. So if we click on this and set it a bit higher, we're doing more math checks per frame. I'm going to set it to 10. Click play. And at least with regards to the cube, things look a lot better. You might have to set this higher depending on your situation. So you may also notice, again, our cloth clips a whole bunch at the bottom. We'll watch it again. And we don't want that clipping either. To fix that, again, we're going to go into the Physics tab here, scroll down a bit, and we're going to click on Collisions. There's actually a bunch of settings here that are worth messing around with. We've got another quality slider. If I roll over that, it says something about how many iterations should be done. I know what that means. I don't know how that translates into a better Blender simulation. However, this is a number you can bump up to try to make things look better. We also have some distance options. So you can increase the distance between your cloth and the objects it collides with. However, if you make this number too big, it becomes too obvious that the cloth isn't coming anywhere near colliding with your object. So this can prevent clipping, but it will also make things look a little bit spaced out. Alright, so down here we have self collisions. This is what we want to check. This should help the cloth collide with itself to keep it from clipping. So with that selected, let's go ahead and hit play. And that looks a lot better. Yeah, we can still see the vertices and edges. If you wanted to fix that up a bit, you could add more subdivisions or goof around with shading modifiers, but otherwise, I think that looks pretty good for now. One more thing I want to look at is if we go all the way to the top, if you wanted to mess with your cloth settings, there's a whole bunch of things here for stiffness and dampening. Play around with those to your heart's content. But otherwise, if you go across from where it says cloth, there's these dots and lines here. If you click on that, we've got a lot of presets. So here, I'll scroll down so we can actually see everything. So I'll go ahead and click on this guy. It's like cotton. You'll see it sets various settings for these various options here. If I were to check on rubber here, you see things are completely different. So again, it's a nice shortcut for goofing around with your settings. Okay, now we're going to talk about fluids, which essentially means liquids and gas. First thing we need when working with fluids is a domain. And a domain is an object that will contain our fluid simulation. So for that purpose, I think our default cube will work just fine. I'm going to make it a bit bigger though. Okay, to make our cube a domain, what we do is go to the Physics tab, click on Fluid, and then for type, set it to domain. Once we do that, our cube is now a wireframe, and you'll notice there's a little smaller cube in the corner here. This represents a voxel, which is essentially a 3D pixel, and it represents the resolution of our fluid. The higher the resolution, the smaller the voxel, and the better definition our fluid will have. The lower the resolution, the bigger the voxel is, and the more blocky our fluid will look like. But obviously we'd save some processing power if we did that. So this is one of those numbers that I want to play around with to help the recording stay smooth. And this is represented by resolution divisions here in the fluid settings. So I'm going to go ahead, and I think the lowest it goes is 6. So if I hit 6, you see our voxel becomes a lot bigger. And you can imagine if we had any sort of fluid with a voxel that big, it's going to look like garbage. It's going to look very blocky, kind of like Minecraft. So I'm going to compromise and set this to 16. And I think that'll be okay. So the first simulation we're going to work with is smoke. And so we need a flow object to add smoke to our domain. So I'm going to go to Add, Mesh, Cube, make it a little bit smaller. And then I'm going to bring it to the bottom of the domain because smoke by default will rise. You do want to make sure that your flow object is inside the domain, otherwise it's not going to do anything. Alright, so from here we're going to go to Fluid, type Flow to make it a flow object, and you see once I do that we get a nice little puff of smoke. In fact, let's just go ahead and hit play and see what happens. So we get a puff of smoke, it rises to the top of the domain, and then once it gets there, it just kind of gathers. The smoke will not leave the domain. If you wanted to remove a fluid from a domain, there's ways to do that, and we'll cover that a little bit later. Let's set us back to the 0 frame here. Now, if you wanted more than just a puff of smoke, if you wanted a constant flow of your fluid, you change the flow behavior of your flow object to inflow. We'll go ahead and hit play here. And you'll see now we get a constant column of smoke. And there's some things we can do to make this column of smoke a little bit more interesting. We'll pause that for now. Again, going back to 0. First thing we can do is an easy one, is change the color. So I'm going to go to smoke color here. We can set it to red. I'll hit play. And sure enough, now our smoke is red. That's about all I want to look at as far as the flow object goes. So I'm going to go back to the domain now. And the domain is actually what controls what the smoke properties are. So I'm going to click on the domain here. And we already messed around with the resolution a bit. But if we scroll down a bit more, you'll notice we have a gas settings section. The first two settings here, buoyancy density and heat, control how fast the smoke rises. And I'm just going to mess with the heat one. And I believe it tops out at 5. So I'm going to go ahead and set the heat to 5. Bring our playhead to 0. Play it out. And sure enough, it rises quite a bit faster. If you want to make our column a little bit more turbulent, what you can do is increase the vorticity. I believe this guy tops out at 4. However, if you go anything above 1, it just kind of looks like a mess. So what I'm actually going to put in is 0.1. Bring the playhead to 0. Hit play. And you'll notice now our column has a little bit more extra to it. It's not just a straight up and down column of smoke. One more thing we can do to make the smoke a little bit more interesting is add noise. And to do that, all you do is click the noise checkbox. If I hit the arrow here, you see there's a couple settings. I'm not going to mess with them. But I'll hit play one more time. And now we have some variance with the flow and a little bit of turbulence with the vorticity. And I think that makes our smoke look quite a bit more interesting. If you roll over the settings, I find these tooltips are actually very descriptive versus some of the other tools in Blender. So go ahead and have a look and play around with those a bit. But I want to look at one more thing. And let's say, for example, you were going to create a cauldron. Rather than have the smoke rise to the ceiling, you probably want it to fall to the floor, make it thick and gross looking. So for that, I'm going to move our flow object to the top of the domain, and then we're going to go back to the domain here, and we're going to set the heat, instead of 5, we'll set it to something negative. So -5, and the buoyancy we'll set to -1. And with negative numbers here, the smoke will fall instead of rise. It looks absolutely toxic. But that's all I want to discuss now for smoke. Okay, next up is fire. For our fire simulation, we're going to start off the same way we did as with the smoke. So we'll use the default cube, make it a bit bigger, go to the Physics tab, Fluid, Type, Domain, and I'm going to set the resolution division to 16. It's up to you if you want to do that. Alright, good. Next we need our flow object, so go to Add, Mesh, we'll do Cube. I think every tutorial I've seen usually sets the monkey head on fire, but I think the cube is fine for now. Shrink it a little bit, and then we're going to go to Fluid, Type, Flow, and now instead of smoke, we're going to go to Flow Type here, where it says smoke, click on that, and we'll choose fire. Smoke plus fire just does both fire and smoke at the same time. Fire actually creates its own smoke as well, so something to keep in mind. So I'm going to choose fire, and immediately we get a different look. I'll go ahead and hit play just to show what we've got. And just like with the smoke, we get a puff of fire and then it goes away, and you can see it created its own smoke a little bit. So if you wanted a constant fire, again, go to flow behavior, change it from geometry to inflow, and now when we hit play, we get a nice steady fire. Now, if you wanted to change the intensity of the fire, just a little bit down, we've got the fuel setting. If we set it to something like 0.1, hit play, you see we have a kind of dim fire. And if we set it to something more like 5, hit play, we get something a little bit different. And again, the fluid is contained within the domain, but otherwise the fire rages on. I believe this tops out at 10. I'm going to set that back to 1 for now and bring the playhead back. So again, that is all on the flow object. I'm going to click on the domain now. And if we scroll down a bit, past the gas, we have a fire section. I'm going to click on the down arrow there. A bunch of settings. Feel free to have a look at them. Of course, we have the vorticity like we did with the smoke, but it already has a setting attached to it. The one I want to look at here is the flame smoke. And you see the tooltip says this is the amount of smoke created by a burning fuel. If you don't want any smoke, you can set that to 0. Hit play. And now we've got fire, but no smoke. I'm going to pause that. You'll notice we have a smoke color, but not a fire color. I did some research into it, and you can set the fire color, but it involves going into the node editor, and I'm not going to go through that today. Next, we're going to look at liquids a little bit. To do that, we're going to go ahead and take our default cube. This time we're only going to resize on the z-axis. So S, Z, and drag that up a bit. There we go. Now to make it a domain, go to Physics, Fluid, Type, Domain. Now this time we have a few more things to do. So for type, we're going to go from gas to liquid. I'm going to leave the resolution alone, but I will come down here and I'm going to check the mesh box. What that's going to do is create a mesh around the particles that are participating in the fluid simulation. That mesh is going to be using the material properties of the domain. So if we want our liquid to have a look, we're going to have to change the material properties of our domain. So I'm going to go to Material, scroll up to Base Color, and we'll set it to green. Maybe like a dark green, so it'll look like an ooze. Okay. So that's our domain. Now we need a flow object, and it'll be a lot easier if we go into wireframe mode. So let's go ahead and do that. And go Add, Mesh, Cube. I'm going to shrink it down a little bit. It should still be bigger than the voxel size. And then I'm going to bring it up to the top. So G, Z. I'm actually going to move it into a corner. So I'm going to nudge it a little bit on the Y and the X axis. You're going to make sure that your flow object is completely within the domain, or it will not work. Okay, so from there, let's go ahead and set the physics properties. We're going to go to Physics, Fluid, Type, Flow. And this time for flow type, we're going to set it to liquid. Flow behavior, we're going to go from geometry to inflow, so it keeps on pouring. And now let's see what we've got. And there we go. You see it fills up the box. It's restricted by the voxel size, so it's not quite getting to the edges. I'll pause it. And the reason why it looks like this is because I'm still in wireframe mode. And like I said, we're actually building mesh around the particles that are in the simulation. So if I'm going to go back here to frame 0, turn on the viewport shading, hit play, that should look a little bit more like what you were expecting. All right. I'm going to stop that, go back to 0. And now this time we're going to set an outflow object. So this will keep our domain from filling up. So again, we're going to go to wireframe mode, Add, Mesh, Cube. I'm going to flatten it out just a little bit. Keep it taller on the voxel. Bring it down to the bottom with G and Z. Go to fluid, type, flow, flow type, liquid, flow behavior, outflow. Let's go back to shading mode, hit play, and sure enough, instead of the liquid filling up the domain, the fluid instead is removed from the domain with the outflow object. You'll notice sometimes we have an opaque domain and sometimes not, and that's just the difference between frame 0 and frame 1. So the animation actually starts at frame 1, so not a big deal. One more thing we're going to do is get something in the way of our fluid. So in other words, add a collision object to the fluid simulation. So we're going to go ahead, go back to wireframe mode, go to add, mesh, cube. I'm going to get it out of the way a little bit so the fluid can still hit the bottom. So GX, GY, make sure it's still in the way a little bit. There we go. All right, so add the shading, hit play. You should have expected that by now because we have no physics attached to the cube yet. So with the last cube still selected, we're going to go to fluid, type, effector. And that will be enough for the fluid to collide with it. So sure enough, it hits the side there and then flows down into the outflow object. So that is all I'm going to cover for liquids for now. Okay, so to finish up, I'm going to take a brief look at gravity and wind. So starting with gravity, let's go ahead and add a ground surface. So add mesh plane, S to resize, and then we'll go to the physics tab here, go to rigid body, type passive. So the ground plane will not react to gravity. Then we'll go ahead and take our default cube here, and then use G and Z to grab it up, lift it up nice and high, and then add physics to it with the physics tab, rigid body, type active. We'll leave that as the defaults. So if we hit play, just as it happened before, our cube falls to the ground plane. This happens because of the gravity settings, and those settings are in the Scene tab. So if we go to the Scene tab here, you'll see gravity is checked. Rigid body world is also checked by default, so if you uncheck that, hit play, you see the rigid bodies do not react to the physics at all. So we want to make sure that's checked. If we click on the arrow for gravity here, you'll see the settings, which by default is set to negative 9.8 meters per second on the z-axis, which if you took a physics class, you know that is the real world value for gravity. So if you wanted to set like a moonscape, you can set this to be something more like negative 1.5. Now when I hit play, you see the cube falls a lot more slowly. And if you want to turn gravity off completely, maybe you're doing some sort of space collision simulation, you can just set that to 0, hit play, and now things are happening. It's just that without any collisions, a body at rest will stay at rest until acted upon by an outside force. At the same time, you can also set sideways gravity. I'm sure there's reasons you might want to do that, but if you just say set gravity on the x-axis for 5 meters per second, hit play, and sure enough, our cube is moving sideways. So this goes for fluids and cloth and everything else that I didn't cover. It all reacts to gravity, and gravity is set here in the Scene tab. Okay, so now for our brief discussion about wind. For this demonstration, let's go ahead and start off with our ground plane. So add mesh plane, S to resize, and then we're going to add a dark color to it for visibility. So material, new, and then for base color, let's go ahead and choose like a dark purple color. For the physics, let's go ahead and choose rigid body, type, passive, so it does not react to gravity or wind for that matter. Next, let's go ahead and grab our cube. And this is going to act as a target dummy for our wind. So we're going to grab it up just above the plane here with G and Z. We're going to make it a little more narrow on the x-axis. So S, X, and make it a little narrow. There we go. Let's go ahead and give it a color. So we're going to want a material, base color, something a little bit lighter. How about cyan? And for the physics tab, rigid body. We're going to leave the type as active, but we're going to set the mass down to 0.1 kilograms to make it a little easier to push. And we'll go down to surface response and set the friction to 0. There we go. Let's go ahead and go to shader mode. So there we go. And let's add a few more targets. So with that, we're going to choose the first target dummy, hit Shift D to duplicate, then Y, and just move it over just a tad. We'll do it one more time. Shift D, Y. There we go. Again, make sure you have a little bit of a gap, otherwise the collisions are going to make everything go all over the place. Let's go the other way with it. Shift D, Y, space, Shift D, Y, and add a little space. Okay, so here's our setup. Now for the wind. There's a couple ways you can add wind to a scene. One way is you can add a force field property to an object. So with an object selected here, if you go to the physics tab, go up to the top here, you click on force field, you see immediately we have an indicator that there's a force field around our object. And then for type, click on force, and you see wind at the bottom. Now there's a whole bunch of different types of force fields. Some of them are easier to use than others. I recommend playing around with them, doing some research if you can't figure them out. But otherwise, we're just looking at wind today because I think that's probably the most popular. I'm going to go ahead and select wind. And when I do that, the indicator changes. You see an arrow pointing in the direction of the wind. There's also a couple of circles that you can't really see here. I don't want wind on my target dummy, so let's go ahead and undo that with Control Z a few times. And instead, I'm going to go to Add, Force Field, Wind. And as I roll over that, you see the tooltip says that we're adding wind to an empty object. So you won't see what's causing the wind when you run your simulation, but that's okay. So now you can actually see some of the circles a bit as our wind object is on the origin. I'm going to go ahead and grab our wind object with G and X, pull it out like that. G and Z, pull it off the plane. And then R, Y, and then I think we want 270 to rotate our wind to point at our targets. I'm also going to hit S and shrink it down a little bit just to focus it a little bit better. Okay, so now we have our empty wind object pointed at our targets. Let's go ahead and hit play and see what happens. Pretty much nothing. The reason for that is because of the strength of our wind. So I'm going to pull this out just a bit here. So you see there's a whole bunch of settings that we can mess around with. I'm not going to touch nearly all of them, but one you should definitely be aware of is the strength. So I'm going to go ahead and bump our strength up to 100. You see when I do that, we've got these circles here that kind of spread out to indicate that the wind is a little bit stronger. If I click and drag on the strength setting, you can see the circles go out and in. Again, I'm going to set this to 100 manually. And let's go ahead and play things now. Sure enough, our target dummies do not stand a chance. So that is a basic way to add wind. If you do it this way, by default, the wind affects the whole world. Now let's say you wanted to focus the wind kind of like an air cannon. To do that, we're going to slide down here a little bit. And for fall off, it's set to sphere. There's actually no fall off at all right now. I'm going to set this to tube. And then I'm going to scroll down a little further here. Now we have a radial section. I'm going to set the power up to 10. That's as high as it goes. And the power, it's not very intuitive, but what it does is it restricts the shape of our wind to the shape of our object. So now I'm going to go ahead and hit play. And sure enough, our wind is focused within the circles of our object. So with that, that's all I planned on covering today. I think physics in Blender is actually a lot of fun. It just requires a bit of research and a lot of trial and error. And with that, I hope you had fun, I hope you learned something, and I hope you have a good day.